Hello there, students, and welcome to your Unit 6 Test Mastery. We are looking at the learning target for sinusoidal modeling. Rather than coming up with some new problems, I just pulled up the worksheet we did way back in Unit 6. I don't even remember the section number anymore, but it was early on in Unit 6. And we're just going to look at, let's start with number 2. So number 2, it says the number of hours of daylight measured in 1 year in Ellenville can be modeled by a sinusoidal function. During 2006, not a leap year, the longest day occurred on June 21st with 15.7 hours of daylight. The shortest day occurred December 21st with 8.3 hours of daylight. Write us an equation. All right, so I'm going to just bring this to the top so we can kind of take a look at it as we're doing this. So I'm just going to kind of give myself a sketch of the graph so I know what's happening. So 2006, longest day was June 21st. I don't know, we're just going to call this June 21st. So June 21st, that's my longest day of the year. That was 15.7. And then way over here is December. That was my shortest. That was 8.3. All right. Now, in terms of being able to create a point out of this, June is my 6th month. December is my 12th month. So let's just do like a standard thing with that. It said leap year, but I don't know that matters. So I guess we have two options for our x values. X could be the number of months, or X could be the number of days. The only reason I can think that you would want to do days is if this date and this date were not both the 21st of the month. Otherwise, I don't know. I guess I'd go with that. Going X's number of days is probably going to be like a nicer thing, but it's definitely going to take us more time. So for the basic idea, let's just go months. So just to be clear, we are doing X as my number of months. So 6, and then this over here is like hours of daylight. All right, let's do this thing. So I've got a basic sinusoidal function that goes like this, and it's going to start coming back up. There are some things I need to know about this thing. First off, I need to know my amplitude. So when we start looking at a function, a times the cosine of your b value and then x minus h plus k. All right, my amplitude is this piece right here. That's going to be from my midline, what's the distance to the top and what's the distance to the bottom. The easiest way for me to figure that out is just to find the total distance between the top crest of this wave and the trough of this wave, and then cut that in half. So here we go. Top is 15.7. That bottom is 8.3. Let's cut it in half. So we do y max minus y min, and then divide it in half. Let's just write that down for those of you. So y max divided by, let's try that again. Y max minus y min divided by 2. All right, so let's do this. I got 15.7 minus 8.3 divided by 2. That means my amplitude is 3.7. That is this value here. Okay, let's take a look at my b value. My b value is going to be 2 pi divided by my period. My period is going to be how long this wave takes to repeat itself. Well, if in June is the tallest and in December, like on the summer solstice and winter solstice, when this thing comes back around over here, it's going to hit back in June again. That's when the summer solstice is. So it looks like that period is going to be like a total of 1 year. So for us, that's 12 months. Or if you go from high to low, that's 6 months. You could take any time you know a high to low, you can find that, and then you can multiply it by 2. So we're going to go 2 pi over 12. I think most of your teachers would prefer you to reduce it, but if you gave us 2 pi over 12, I don't think any one of us would say that you were wrong on that. We would just say, hey, can you reduce that? All right, that's my b value. Done. Okay, h value. H value is why we use cosine. This is just going to be what phase shift do you have to the right. So normally cosine starts on your y-axis. It starts up top. So whatever your first y max value is, that's your phase shift. So when I look at my h value, let's make sure we can actually see this here. When I look at that phase shift, it is going to be, h is simply going to be my first x max value. Actually, it's any x max value. I'm going to go for the first one because I don't feel like talking about years in the future. So for us, that happens in June. That's going to be 6. All right, K. K is your midline. Normally, your cosine function goes above and below at the same amounts. This one, the whole thing has been shifted up. So I need to know, what is this line that's my middle? Well, to figure that out, it's just going to be halfway between 15.7 and 8.3. There are all sorts of ways to figure that out. I mean, you figured out amplitude. You could add that to your 8.3. You could subtract it from your 15.7. For me, I simply prefer to take my y max, my y min, and I just add them together. And I divide it by 2. So let's do this here. I've got 15.7 plus 8.3 is 24. Divide that thing by 2. It looks like my midline is 12, which makes sense that your midline is going to be 12 hours of sunlight a day. Okay, let's put all of this together. So, I probably shouldn't do a y equals. That's more algebra 1. Let's go hours of daylight based off my month. Remember, I made a choice as to what this was. I'm going to let the reader know that I'm choosing months though. So I've got h of x. I'm going to let x be my month. And then I just start plugging in values. This is 3.7 times the cosine value. My b is pi over 6. X minus 6 plus 12. Quick little thing. If you try and put brackets into your calculator or brackets into Desmos, it's going to freak out at you. We're using brackets here just because it's a helpful way to say, hey, this is a grouping symbol, and please make certain that your phase shift is grouped with your x value, and then your b value is multiplied by that entire thing, and it's cosine of this whole group. But otherwise, you're going to have to use double parentheses if you're using a calculator or Desmos. All right. On the next one, we will do number 3 of the worksheet for applications of sinusoidal functionings. But if this is all you needed, great. I'm glad. Have a lovely day.